Greetings, Earthlings. Today we're going to go over whether we can build the perfect protractor. Now, how did this video come about? Well, after doing the sand videos, I began wondering, okay, clearly that's not accurate, so let's talk about straight edges and compasses. And so I began thinking, how do they make protractors? We take it for granted. We buy it at a store, so here's a cheap protractor. But how do they make sure that these angles are what they say they are? How do we know that they're not lying, or they're not a little fudge, they're not a little off? So the short answer is, I want to be completely honest with you guys, I don't know. That said, I'm going to give you my current thoughts. So my current thoughts are that no, this is not perfectly precise, and it is possible that it will never be perfectly precise. So, or at least not with today's technology. So that I'm leaning towards that this is not possible, at least with today's technology. Why might this be the case? Now, also, before I go into that, I just want to make a quick note that I strongly suspect the presentation I'm giving you guys in this video is incomplete, in the sense that there are probably some really cool things or relevant things that can be included to improve the presentation. And I hope that in the future, so either I do this or somebody else takes it upon themselves to give an even better presentation on this topic. But I just want to, apologize in advance for any potential oversights. But hopefully this is still useful and gives you guys ideas and serves to kind of catalyze those future, even better videos. All right, so with that incompleteness note, caveat out of the way, this is my little math joke. So this is y, for those of you that aren't familiar, and 0, we can read this as y sub 0, but another name for 0 you might hear in mathematics class is naught. So why not? That's my little math joke. So how come we can't do it? Why not? So one really fundamental reason is, if you want to build something, you're using either your hands or other instruments, and no matter what instrument you're using, so let's say I'm using a ruler, all of our instruments have imprecision built into them. So literally every instrument we use is imprecise, whether it's a watch, whether it's a ruler. So like for example, in this ruler, these markings they're pretty close, but they're fairly precise, but they're not exactly precise. And so if I'm going to measure things with something that's not perfect, clearly what I'm trying to do won't be perfect either. So that's just going to translate and have a downstream ripple effect. So the point being, whatever gadgets they used to cut out this thing were themselves not completely perfect. So although this is supposed to be a half circle, right, a semicircle, whatever was arching this way may have not been a super precise circle itself. On top of that, let's talk about the markings. This is like an obvious one. So on a protractor, you have markings, 90 degrees, 100 degrees, even up to the degree. So I'm just gonna move it closer so you guys can see. So you have these little tick marks, right? And so the little tick marks, the smallest ones on this one are 1 degree. I don't know if you guys, maybe if my hand stops shaking, you guys can actually see it. All right, so anyway, so you have these little 1 degree tick marks. And tick marks, unlike in mathematics, when we say we're going to draw a line, we assume it's an infinitely thin line, but in real life, all lines have a little bit of a thickness. So every tick mark has some thickness, and that's what I'm just showing in this diagram. Each of these blue things, let's say, is a tick mark, and the tick mark has a little bit of thickness. So I'm just going to blow it up. Let's say this is your whole tick mark. So if I'm going to make a notch for, let's say, 80 degrees, how do I know if the notch goes here or here or here? Because I don't have that much precision. It's not an infinitely thin tick mark. That may seem like a minor point, but it's kind of important. here's the thing. So what we're not going to go into this video, which I'll go over in the next video, is probably a question you guys are wondering. Who cares? Who cares if it's not super precise? It seems precise enough. And that's what I'll address in the video. What's good enough? What's precise enough? All right. So hopefully that gives you guys some ideas. Oh, so like let me give you guys another analogy. Let's say for imprecise instruments, you guys know that every year computers get faster and faster. We have better and better processor chips. And the thing is, you can use faster computers and better computers to design even faster chips. So the counter argument might be that if we're getting kind of more precise and faster every year, then maybe we will reach kind of like a best or fastest or, you know, a state of perfection. That is very possible. So I don't know. I'm saying with today's technology, it's not yet possible. If it is possible, I suspect it would be because we reach some sort of physical limit of the universe, let's say like the Planck scale, Planck, where there's just no more imprecision to be had. But that gets into like quantum mechanics and what you think is happening there. So I don't think I know, or maybe we don't know yet, but the bottom line is with today's technology, I don't think we can make super precise instruments. We can have more precision and less precision up to our current technology, but not perfect precision where we have zero error. Now, some tips. Let's say you want to build your own protractor. There's some like really crude ways. I mean, you could take a semicircle, use a compass, trace out a semicircle, maybe cut it out, fold it in half, you got your 90 degrees, fold it in half again, you have 45 degrees. So you could do stuff like that to maybe draw some hexagons, you can get some 30, 60, 90 angles going. But what if you want to get 1 degree or like 3 degrees or 17 degrees? I just want to give you guys some tips, and hopefully this gives you a few ideas to think about. That's my main agenda. I don't want to just kind of limit ourselves to this topic, but just, you know, all these videos are meant to just get you guys thinking and, you know, be useful for you guys' development. So should we make a small protractor or a large protractor or a medium protractor? So here's the thing, if you make a small protractor and you're a little bit off, like let's say you're gonna eyeball 1 degree, if you're a little bit off, once you extrapolate that, that's gonna be way more off. So if we're like a little off here, and then it's gonna get larger and larger. So with that in mind, you wanna make a large protractor, because then if you go in, let's say you made a huge protractor, like the size of a human. If you then go in, whatever your error was is going to start, let's say you were a little off. You said that was 1 degree, but it was really like 1.3 degrees. When you go inwards, that error is not going to be magnified. Whereas if you were a little off on a large scale, as you create larger and larger drawings, that's going to be magnifying your error. So my point is, I'd recommend using larger instruments rather than smaller instruments to get more precision. Next, if you really want to get deeper into it, you should check out trigonometry. That is one way to get more precision. Now, I haven't covered trigonometry on my channel yet. I do have a few trigonometry videos, but those were just some requests that I had. I haven't, as of this video's date, I haven't gone into the introduction to the whole trigonometry series, but I probably will at a future date. So you could stay tuned for that, or start looking into trigonometry on your own. And what that is basically the mathematical study of angles and going between angles and lengths. So if I told you we're going 3 feet this way and 7 feet up at 90 degrees, that creates a unique triangle, and so you could then tell me what this angle was between the horizon and this slant. So if you know the mathematics of how to do that, then if you want a 37 degree angle, you can go out an arbitrary number of feet, let's say 12 feet, and then you would know, according to trigonometry, I need to go up a certain distance vertically to create my 37 degree angle right over here. So that's what trigonometry would do for you. Now, keep in mind, it will add precision, but when drawing all of these lines, there is still imprecision. So it doesn't solve our problem, but it may make it more accurate than kind of eyeballing or folding a paper or stuff like that. Now, for my current knowledge, and I could be out of date, you know, I would love if some of you guys in the comments pointed out something even better. I know there's a lot more, for example, in physics, there's a lot more precision when they're measuring electrons and radioactive decay. But as far as protractors go, it seems to me that one of the, like a common, maybe not super state of the art, but a common good precision tool is a digital protractor. So instead of using this baloney, you get, and it's actually called the, I don't even know how you say it, a goniometer, a goniometer. And it's literally two things that when you change the angle, there's a digital reading right over here, and you guys can Google it, I'll put in links. It'll tell you like, oh, we're at 101.6 degrees, 101.5 degrees, 90 degrees. That's gonna add some precision. That's gonna be pretty cool. So as far as like for the average person, what's as precise, like what's the most precise thing you can get in your house? It might be a goniometer, and they have different precisions, like 0.1, 0.01 degrees, maybe even 0.001, I'm not sure. But that would be useful, let's say if you're in architecture or you're a machinist and you want to cut out things with a high degree of precision. Anyway, hopefully you guys found this interesting. It gave you some things to think about. I know it gave me some things to think about. And you know, I encourage you, as you're going through your daily life, just think about why things work. How I never, you know, in all my years, I never thought, or maybe like when I was a student, I thought about this, but then I never really pursued it. Like, how do they make a protractor? And you'll be shocked. Most people, including myself, you know, most people don't know. All right, I will see you guys.